Next continuation. Variable mass system and its motion. Variable mass system, variable mass system and its motion. Variable mass system and its motion. So what is the mass system? Whose mass varies with time is said to be variable mass system. Here we have two diagrams. So time t, velocity v and mass m. So what is the mass system? The mass system whose mass varies with time is said to be variable mass system. Here mass m, whose center of mass is moving with velocity v at time t. Here mass m moving with velocity v at time t. After some time, at a later time, t plus delta t time, t plus delta t time, a mass delta m has been coming out from the system, coming out from the system, and its center mass moves with a velocity u. Its center mass moves with a velocity u. Now the system mass is reduced to m minus delta m. Here system mass m minus delta m. So first of all consider what is the mass system means. Whose mass varies with time is said to be variable mass system, and here mass m moves with velocity v at time t. So after some time at t plus delta t, a mass delta m has been coming out from the system, and its center mass moves with a velocity u. Now system mass reduced to m minus delta m, and the velocity of the reduced mass system is increased up to v plus delta v. V plus delta v. So the system represents a motion like of a rocket. Okay. So from diagram we can say that here consider mass m moving with velocity v at instant time t. After some time at later time, from that system center delta m moves with velocity u t plus delta t time, and system mass decreased m minus delta m and velocity increased v plus delta v. A mass system, the mass system, the mass system whose mass varies with time, with time is said to be is said to be variable mass system. Variable mass system. A system of mass m, a system of mass m whose center of mass whose center of mass is moving with velocity v, is moving with velocity v, velocity v, as seen from a particular reference, from a particular reference at any instant, at any instant t. At a later time, at a later time, t plus delta t, t plus delta t, a mass delta m, a mass delta m has been coming out, has been coming out, coming out from the system, from the system, and its center of mass, its center of mass moves with a velocity u, moves with a velocity u, as seen by an observer. At a later time, t plus delta t, a mass delta m has been coming out from the system and its center of mass moves with a velocity u, as seen by an observer. Next, now the system mass is, now the system, now the system mass is reduced to m minus delta m, m minus delta m, and the velocity, and the velocity of the reduced mass system, of the reduced mass system is increased is increased up to V plus delta V. Now the system mass is reduced to m minus delta m, and the velocity of the reduced mass system is increased up to V plus delta V. After that, the system represents the system represents the system represents a motion like of a rocket. A motion like of a rocket. Next, now according to Newton's second law of motion, we can write F external dp by dt equal to, we can write momentum final minus momentum initial by delta t. Now according to according to Newton's second law of motion, Newton's second law of motion, force dp by dt equal to, so final momentum minus initial momentum by dt. So here final momentum m minus delta m into v plus delta v plus u into delta m minus initial momentum m into v by dt. So final momentum m minus delta m into v plus delta v plus u into delta m. So initial momentum minus m into v by dt. So from this equation we can write m into v plus m into delta v minus delta m into v minus delta v plus u into delta m minus m into v by dt. Plus m into v minus m into v cancel. Here m into delta v by dt minus v into delta m by dt plus, next this term, u into delta m by delta t minus delta m into delta v by dt. Here we can neglect this term. After neglecting this term, we get next equation, that is